Orthogonal diagonalization, and some kind of a ghost looking at me. This must be a really scary topic. Now, we've seen scary stuff in linear algebra, but between the name and the image there, this better take the cake. So let's see what we're looking at. Alright, so first of all, let me introduce what we're going to be looking at. Actually, I'm going to introduce that by summarizing some of the things that we've seen in the last few lectures. The first one is that we've seen not long ago that diagonal matrices are nice. In the sense that they have all kinds of nice properties, and you may want to review what those are. Also, orthogonal matrices are nice. We've seen that they have some pretty nice, neat properties as well. They're a special kind of matrices. And we've also seen that similarity is also a nice thing. It allows us to transform one matrix to another one which is similar to it. And related to that, diagonalizable matrices are nice. They're the ones which are similar to diagonal matrices. And therefore they inherit some of the properties of diagonal matrices. Okay, what else do we know? Well, let's see. How nice would it be to get an orthogonal diagonalization? Wait a minute. Two things here. First of all, everything is nice except for the title of the topic and the little ghost that is still staring at me. Secondly, how nice would it be? I don't know. Would it be nice, or would it make things just complicated? And to begin with, what does it even mean? Alright, so let's have a look at first of all at what we mean by orthogonal diagonalization. So, a matrix A is orthogonally diagonalizable, and if you can pronounce that, you're already on the right track, if it is diagonalizable by means of an orthogonal matrix. Now remember, what does it mean for a matrix to be diagonalizable? It means that it is similar to a diagonal matrix. How similar? Through some kind of invertible matrix. Well, that's the one that we're going to require to be orthogonal. So a matrix is orthogonally diagonalizable if we can write it as a product like that. It's an orthogonal matrix Q times a diagonal matrix D times the inverse of the orthogonal matrix Q. Now remember, the inverse of an orthogonal matrix is what? Yes, the transpose of the matrix. This is going to come in very importantly in what we're about to see. So since Q is orthogonal, that means that I can also write an orthogonally diagonalizable matrix as Q times D times QT. Alright, let me give you an example of what an orthogonally diagonalizable matrix might look like. Okay, so how do we construct an example? Well, all we have to do is pick a diagonal matrix and an orthogonal matrix and multiply them together according to that formula that you see in front of you, and we'll get an orthogonally diagonalizable matrix. Let's see. So let's start from an orthogonal matrix. Now, this is not A, this is a Q, right? So A is going to be equal to Q, so what you have in front of you is just the orthogonal matrix Q. And I picked that one just because, so I liked it. Now let's pick a diagonal matrix. So a diagonal matrix will look like this, and I'm just picking small numbers so that things are not going to get too complicated. Now notice that, of course, for an orthogonal matrix, I'm pretty bound to my choices. The numbers, the entries in a diagonal matrix end up always being quite messy. However, the nice thing is that when I look at its inverse, once again, it's its transpose. That's easy to do. So all I have to do is just transpose the matrix. Now, what you may want to do, just for your own fun, is pause the video here, put all those three matrices in your calculator, and multiply them all together. If you're lazy and you don't want to do it, well, here is what you're going to get. Well, that's an orthogonally diagonalizable matrix, right? So that's all there is to it. And that's just, notice anything special. Special about what? Special about that matrix. Do you see anything special about that matrix? What am I supposed to see? Oh yeah, those two numbers are the same. And what else? And those two numbers are the same. Interesting. And those two numbers are the same. Oh, I get it. That's a symmetric matrix, right? So this is what a long time ago we called a symmetric matrix. Oh, cool. So I ended up with an example for which actually this orthogonally diagonalizable matrix ended up being symmetric. But is that a coincidence? Is that just a special case? A lucky kind of situation? I just happen to choose my matrices very wisely? Or is it a general property?